previous videos, we have discussed modeling level 1 and modeling level 2, and we go into the details of deriving the models. For the sake of completeness here, I'm showing you the illustrations of how modeling level 3 and level 4 can be performed for the same problem. But we will not go into the details of the derivations in here because it gets more complex for level 3 and level 4. So for example, if we pay attention on the level 3 modeling, which is defined by the illustrations on the left hand side of this particular screen, then you can see that unlike the level 2 model, we make the modeling a bit more complex by basically considering the temperature variations not only on the top of the solvent air interface. So as we can see, we have two differential shell elements in here. We have the differential element above the solvent air interface, and we have the differential element below the solvent air interface. So if we do the steady state heat balance on the top shell element, we will get one second order ODE. Then we need to solve it using boundary conditions at this point and also at this point in here, at x equal 0 and then at x equal L2. Note that for this particular conditions in here on the top, the direction is going out from the shell element. As you can see in here, T1 is basically higher than the T1 in here, and then this one in here is T2, and then we have the temperature of the air atmosphere defined as the T0 in here. Okay, so we will get one second order ODE by formulating the energy balance on the top shell elements, and then on the bottom shell elements again, if we formulate the problem, we also get another second order ODE, and then which we need to use two boundary conditions again. This boundary conditions at x equals 0, and then at another boundary at x equal minus L1, because we take at this point x equal 0. Okay, so it's essentially level 3 modeling will involve solving two second order ODE with 4 boundary conditions essentially. Okay, so that makes solving this modeling level 3 becomes more complex than solving the modeling level 2 or modeling level 1. For those that are interested with the modeling level 3, I can give you the steps to derive that thing, but I think I will not put it into the canvas, only for those that are interested. Modeling level 4 is one step higher than level 3. So in modeling level 4, essentially we assume that the rod diameter in here, okay, is comparable with the rod length. So in such a situation, basically the radial heat conductions cannot be neglected. So we have in modeling level 1, modeling level 1, we basically neglected the heat conductions and the heat we only consider a very simple model. The heat conduction is basically neglected, and then in modeling level 2, we take into account the heat conductions on the top, on the rod on top of the solvent air interface, and then on the modeling level 3, we take into account the heat conductions at the in the rod in the bottom of the, just below the solvent air interface and above the solvent air interface. On modeling level 4 in here, we are not just taking the heat conductions on the x direction but also on the air directions. So if I basically illustrate in here. We have the radial heat conductions along these directions in here, and then also another conductions in these directions in here, which make it more complex. So we need to take into account this Q in here, QR at R, and then this one in here is that QR at R plus delta R, and likewise the one in here is Q at X, and then in here the heat conductions at X plus delta X. If we follow this level 4 hierarchy, what we will get in here is basically a partial differential equations. So it will be much more complex than level 3. Basically, we will deal with a lot of series and then Bessel functions and so forth. The key take home message for this modeling is that depending on how you want your model to be accurate, it's not necessary that your model is like you don't need to go into the modeling level 3 or modeling level 4. It really depends on what is the purpose of your modeling. So of course, the higher the level of the modeling, meaning that your assumptions will be more you don't have to put as much assumptions, so you can relax more assumptions. But of course, that also depends on the purpose of your modeling. So for most of the problem that we will deal with in transport phenomena, we will not go into the modeling level 3 and 4, and so you don't need to be worried too much. We will only go into the modeling level 1 and level 2. So most of the models, and I would say like 80% of the model that will be covered on the transport phenomena will be of the type of the level 2 and level 1. But the other thing that we want to show in here is that once you go above that level, you can analyze the validity of the model one level below that thing. So, but having said that, your mathematical skill should be quite good for you to be able to basically derive and formulate a more complex model. Okay, so thank you for listening to this week video, and please you can send me any message if you have anything that you want to ask. Okay, thank you for listening.